Hello and welcome to the channel. This video is a special edition of an introduction to Excel VBA and macros in just 1 hour. But what is a macro after all? An Excel macro is a set of programming instructions that automates tasks in Excel. And Visual Basic for Applications, or VBA for short, is the programming language used to code or write the macros. Using Excel VBA macros have the following main advantages. So now let's open Excel and let's add the Developer tab. The Excel Developer tab gives access to the VBA programming environment and some additional VBA developer tools. If you don't have it yet, go to File, Options, Customize Ribbon, or simply right-click the Excel ribbon and select Customize Ribbon, and then tick the box for Developer and click OK. The Developer tab allows to launch the Visual Basic Editor, where we can create and edit the macros. It also gives access to the list of available macros here, and the macro recorder, and some macro security settings, the add-ins browser, forms and control, and ActiveX controls here, and the XML data manager. Now select the Developer tab and click Visual Basic, or you can also press Alt F11. This will open the Excel VBA editor window. In the VBA editor window, we can see the navigation tab up here, and then the standard toolbar just below. And we can show additional toolbars by right-clicking anywhere in the navigation or in the toolbar and selecting the toolbar needed. You see here, we can select the edit, the debug, and user form. If you don't see it, just right-click and add the standard toolbar. I generally use the standard toolbar and the edit toolbar. So we are gonna see most of the tabs here in the course of this training. For now, let me only show you the tools. Here you have some options of the VBA editor that you can set. For example, you can set the size, the font size of the code. I put it 12. I think by default is 10. I made it a little bigger. You can also set the background. I have a normal white background and black font, but you can change it as you wish. You can also change different things here. The other thing I change is the tab width of the indent. It's usually 3 or 4, and I make it shorter because I have a lot of indentation. So you can change all of that here. And the other thing you can do here is to set your VBA project properties. You can put the project name, you can make a description. This could be useful if you share your macro with other colleagues. You can also protect your macro to lock your project here with the password. So if you send it to someone, they will not see it. Now, here on the left, we have the VBA Project Explorer. And this looks quite like any Windows Explorer, any File Explorer or whatever. Well, initially, we just see a folder for each of the sheets in the workbook. We have 3 sheets, so we have here three folders. And then we also see this workbook. If you don't see the VBA Explorer, you can click here if you don't see that. And the same for the properties window here. If you don't see, you can just click this icon here to see the properties window. And the properties window, it shows you for the selected item here, in this case is sheet 1, it shows you the properties for that object. The properties window is very, very useful when we work with Userforms. But we will see that much later in the training. The last thing I want to say here is whenever we create macros and we have macros, we need to save the workbook as a macro enabled. So if you go here and you save the macro, just remember to save it as a macro enabled. It's a XLSM extension instead of XLSX. Modules can be seen as folders of the VBA project that contain the executable code of macros in the form of procedures. And a procedure contains the executable code that performs a specific task. Let me show you all this in the Visual Basic Editor. The VBA project window shows folders for each sheet in the workbook and also the folder This Workbook. These are actually object modules, a special type of module, and they can contain procedures and code. Most of the executable VBA code is written into standard modules though. We refer to those simply as modules. Let's insert a module here. We can see all the modules in the VBA Project Explorer here on the left-hand side, while the space on the right-hand side is dedicated to the procedures and the code for the respective module. Now, to add a new procedure, we can go to Insert, Procedure. Alternatively, we can also add a procedure manually, writing the statements in the module window. So that was actually our first macro. When running the macro, it just displays the message hello. Now, back to the other types of procedures. The function procedures are similar to the sub-procedures with the peculiarity that they return a value. Let's see an example of a function that converts Fahrenheit degrees to Celsius. So the function takes the temperature in Fahrenheit degrees and returns the temperature in Celsius. And we could now use it in any other macro. So for example, in our first macro above here, and let's say we know the temperature in Fahrenheit, but we want to display here the temperature in Celsius, so we write temp Celsius, which is our function, and in parentheses we write 90, and then when we run that macro, it's going to call the function, and finally it's going to display the temperature in Celsius. We can also access that function as a formula from any cell in the workbook. So if we have here the temperature in Fahrenheit, let's say in column A, we can get the temperature in Celsius in any other cell, let's say in column B, and then here we just use it as a normal Excel formula. Temp Celsius, here we have it already, you see, and in parentheses we refer to the cell A2 here in column A, and then we get the temperature in Celsius degrees. There's yet another very important type of procedure. That's the event procedure. Most of the times it specifically refers to the workbook and worksheet objects. And in that case, it can be inserted in this workbook and the respective sheet object modules. So these event procedures contain executable code that is triggered upon a particular event happening. So let's navigate to this workbook module and have a look here. We select workbook on the left, and on the right, we get the list of event procedures. By default, we always get the workbook open event procedure. That's probably the most commonly used, but we can add any other. Like before close event, we just select and we can add it here. So now, any code here, let's say here in the open workbook event procedure, will run whenever the workbook opens. So if we add a message box here, it will pop up when the user opens the file. So let's say MSG box, welcome to my file. If we close and open this workbook, you will receive this welcoming message when you open the workbook. Similarly, the event procedures in the worksheet object module respond to events at the sheet level, such as sheet activation, sheet range, or cell selection change, etc. The next thing we're going to cover is how to run a macro. And you've seen already a few ways of doing that. Probably the most common way is to go to either the developer tab, or for users who don't have the developer tab, they can access the macros under the view tab here, and then view macros. It will pop this box here with the available macros, and then you can run it. There are other ways to do it. Another way is using the play button here. We've seen it earlier. That's usually when you are testing or working on the macro, you use this play button. We can also add a button here. So if we go to the developer tab, we can insert a button here. So we can assign the macro and it will run when we press the button. We have covered modules, procedures, we wrote our first macro, and we learned the different ways to run a macro. Every element in Excel is represented by an object in VBA. VBA can get the attributes and state of those objects, as well as modifying their attributes and state through properties and methods. A property is an attribute of an object or an aspect of its behavior, such as color, size, etc. A method is an action that can be applied to an object, like for example, open, copy, etc. The general VBA object structure uses a dot or a period as a separator between the object and the property or method. This picture shows some of the most common VBA objects. The application object represents the entire Microsoft Excel application. Within the application, there are workbook objects, and each workbook has the respective worksheet objects, and then range objects and cells, etc. So, for example, if we want to refer to a particular range in the active sheet, we would write something like this: range A1 D8 dot select. In this case, we select that object. We could also copy or assign a value and many more things, but we'll get to that. Objects of the same type form or belong to a collection. For example, the workbook object is part of the workbooks collection, and the worksheet object is part of the worksheets collection. So to select a particular sheet, let's say sheet 1, we can use either the sheet name or the index. So worksheets sheet 1 dot select, or we could also write worksheets 1, that's using the index dot select. Objects are arranged in a hierarchy that needs to be followed. In order to refer to a range in other sheet, we need to specify the path within the object hierarchy using the dot separator. So for example, if we want to refer to a range in sheet 2 instead, we would write worksheets sheet 2 dot range dot copy. For example, in this case, we copy the range. Or if that should always apply to whatever sheet is active, then we write active sheet dot range and so on. The object hierarchy can go even farther if we want to reference a range in a particular sheet of a particular workbook of the Excel application. So we would write application dot workbooks book 1 dot worksheets sheet 2, for example, dot range A1 to D4 dot copy. As we saw earlier, we get or modify the attributes or state of objects with properties and methods. And actually, objects can also respond to events. We will see that in a moment, but let's start with properties. Properties are attributes we can get from or give to an object. For example, the name property of the application object returns the name of the application we are using, and that's of course Microsoft Excel. Remember that properties can either get or give modify attributes. In this case, we just get the name attribute of the application object. Let's see another example where we're gonna give or assign a value to cell A1, and we will use the value property of the range object. So we write range A1 dot value equals 10, for example. So again, we are using the object dot property structure. But here we pass or assign an attribute, the value 10. And what are methods? Methods are actions that can be applied to an object. Let's see some examples. To add a new worksheet in the active workbook, we would write worksheets.add. So object or collection in this case, dot the method add. Note that we wrote worksheets and not worksheet. Most of the properties and actions for a worksheet need to specify the particular sheet or worksheet within the worksheets collection, and therefore we write worksheets with S. So for example, sheet 1 dot delete. Now we are using the delete method of the worksheet object. Now let's talk about events. Objects respond to various events that occur, such as opening or closing a file, changing the selected worksheet or range, etc. Excel VBA allows to handle certain events with event procedures. We already saw the example of a workbook open event procedure. For that, we need to go to this workbook, select the workbook object, and get the workbook open event, which shows by default. And whatever we write here will run when the workbook opens. The range object represents a container of cells in a worksheet, which are the ultimate recipient for the data in Excel. We refer to a range in a worksheet with range followed by the address with the column letters and row numbers surrounded by double quotations in the parentheses. But let me show you in the VBA editor. Range A1 D4 select, and I'm going to use the select method to make it visible in the worksheet for now. We will talk about other properties and methods later. We can refer to several groups of cells using a comma separator between each range. So range A1 D4 comma F6 H12, and if we run that, we will get both groups of cells. And we can also refer to a named range by simply putting the name in double quotations, and that would be, for example, range, my range, select, or whatever. I'll comment that because we don't have such a named range now, and it will prompt an error. And you probably know by now that we can use the apostrophe to add commentary to the code, or while testing to not run some parts of the code. We can refer to any selected range simply with selection. If no range is selected, the selection is just one cell, which is the active cell, referred to as active cell in VBA code. So we could write selection copy. This would copy whatever range is selected, or active cell dot copy, or any other method or property that would refer to the cell which is active at that moment. We can refer to the entire row or column with either the range object or the rows and columns properties as follows. So I could write range A select, and that would be the same as writing columns A select or columns 1 select, and the same for rows. And as we've seen earlier, we need to follow the object hierarchy to reference the range in other worksheet or workbook. Otherwise, the range refers to whatever sheet and workbook is active when running the macro. So if we want to select the range in sheet 2, we would write worksheets sheet 2 range A1 D4 select. And if you want to select a range in other workbook, we just add here workbooks, for example, book 2. We can also just select one cell with a range. We would say range A1 select, right? But we can also use cells. So this range B3, it would be the same than writing cells dot item and 3, 2. So first the row and then the column, or simply cells 3, 2. As we've seen earlier, the value property is a read-write property of the value of a cell or a range. We can get or give the value. Let me show you range A1 dot value equals 10, and I'm gonna move to the previous sheet here, or range B2 dot value equals salary. This is a string, and if we write double quotations, like empty double quotations like this, then we clear the value of the cell. The font property of the range returns a font object that can take several other properties such as name, size, color. So we could write range A1 to H20 dot font dot name equals Arial, for example, or we could say size font dot size equals 14, and let me play that, but in this other sheet. So you see now we get a bit bigger font here. So the interior property returns the interior object or background of the cell. And then we have the borders property, which represents the third part of the cell along with font on interior. Now let's see how we copy a range or cells. And we use the copy method for that. So we just simply write range A1D4 dot copy. Okay. And then we can paste it in any given range in the same or in other worksheet with the paste special method of the range object. But we can also use the range destination attribute of the copy method to do that. And then we can do that in just one line of code. So space range H1. So in just one line of code, we will do the copy paste operation. Variables are used to store data in the computer's memory. And that's the data or values that we usually need in the macros to perform the different tasks. Here on the left, you see the different data categories in Excel. And on the right, the VBA types of variables. So usually, they correspond to the different data types. So for example, the currency or the date variables here exactly correspond to those data types over there. The integer, long, double, those store numbers. And the string is for text. So then we have other that do not necessarily correspond to the type of data, such as the Boolean variables, which only requires 2 bytes of memory, and it can be either true or false. And then we have the variant variable type, which can store any type of data. Variables should always be declared. We do that with the following structure. Dim my variable as a data type. So dim stands for declare in memory. My variable is the name of the variable we're declaring, and data type is just what we've seen in the previous slide, is the type of variable. So it can be a Boolean, an integer, etc. Then we can assign the value to a variable with this other expression here. So we just use the equal symbol. Let's move to the Visual Basic Editor and see some examples. Variable names must begin with a letter and cannot have any space or special symbols and cannot be longer than 255 characters. So for example, dim my name as a string, or for example, dim available items as an integer, or dim delivery date as a date. We can also put that in a single line using a comma separator. We can use option explicit to make variable declaration mandatory. If we add option explicit and we do not declare a variable, we get an error. That's added here on the top at the general declaration section. So it's good practice to ensure we declare all the variables. Now let's assign some values to these variables. So for example, my name equals John. Available items equals 100. Delivery date, so yeah, any date here. And we can of course pass information in the workbook into the variable. So name equals range b2 dot value. And also we can write into a range or cell the value of a variable. So range d8 dot value equals delivery date. So if we play this, we get the date here. We can perform mathematical operations with numerical variables or concatenation or other text manipulations with the string variables. So let's put this in other procedure. And for example, the total cost is going to be equals the number of items times the item price. Or my full name equals my name and we have a space here and my surname. And of course we should declare all those variables before. So up here, dim total cost as an integer, number of items as well, item price, etc. Variables can be declared at different levels in the VBA project. So far, we have just declared the variables at the procedure level. So they are only available within that particular procedure. And they hold the value only until the procedure ends, if declared with the dim statement. Let me insert other module to show you this. We're going to use the variable available items, declare as an integer, and we will add 1 to the value like this. Available items equals available items plus 1. And then we display the value with a message box. So message box, the total items is available items. But if we run the macro, it's always going to give just 1. Because the variable only exists inside this procedure and until the sub ends. Then the value is reset. Now, we can keep the value in the computer's memory after the sub ends using a static instead of dim. So if we change here a static, now if we run it, items is 1 and then 2 and 3, and it keeps it in memory until we edit the code or we press the reset button up here. If we want a variable to be available to other procedures, we need to declare it at the module level up here in the declaration section. If we use here dim and I remove it from here, now it's declared at the module level. And it behaves as a static, so it holds the value until the project is reset. And that's how we use variables in Excel VBA. Conditions are essential to any programming language, and they behave similarly to all of them. In Excel VBA, there are two main types of conditional statements: the if statement and the select case statement. We can check if a condition is met and then do something about it with the following expression. The condition is determined with any of the following relational operators. Let's say we want to check the age of a user. We'll use the variable user age. So for now, I will just put user age equals 16. Then an example of the if statement would be something like this. If the user age is less than 18, then message box not allowed. So if we play this, it shows not allowed. If we change the age here, let's say now 20, and now we play, nothing happens. The condition is not met. We can also put that in separate lines, but then we need to have the end if statement. So here it's not really needed, but we'll see later some examples. So we need that when there are more conditions, usually. In this example, we have used the less than operator, but we can use any other instead. If we say greater than or equal and greater than, then message box, we could write instead allowed. And we can add more conditions with the logical operators. So if we add here user older than 18 and user age is less than 65, for example, we could write in the message box active population. So if I play, now it says active. But if I change the age to 70, nothing happens. That condition is not met. Now we can do something else when the condition is not met using the else statement. So here, if we add else, but let's remove that older than 65 to make it simpler. So if it's greater than 18, it is allowed, yes. Else, here we have another message box, it says not allowed. So now we play, and it says is allowed. But if we change the user age to 16, for example, and we play, now it says not allowed. And we can cascade more if statements with else if. Now we're going to talk about loops. They allow to repeat tasks a given number of times or as long as needed. We may want to loop through a data set within multiple rows or columns or cells in a worksheet, or even through different worksheets or different workbooks. There are basically two types of loops, the for loops and the do loops. With for, we can loop a defined number of times and execute any code between the for and the next statements. So there are two possibilities, for with a numerical variable, or for each, which is used with an object variable to loop through a collection or an item or element for an array. So let's see some examples for a for next loop. To loop from 1 to 10, we write, and let's declare the variable num for number. So for num equals 1 to 10, and then we can display here the number in a message box, so msg box num, and then next num. So this will loop from 1 to 10, and it will display the number 10 times. So we can use this, for example, to loop through rows. So let's see another example with rows. Now I'm going to change, instead of num, let's have r. R, that stands for rows, and for r equals to 1 to 10. And now let's add the value of the row to each cell in column A. So we would write cells in parentheses r, comma 1, so the row, comma the column, dot value equals r. And then finally we have here next r. We change here r. So if we run this, it adds the row number to each cell in that from 1 to 10. So we can also use conditions inside the loop to check or find a value. For example, let's say now we read the value in the cells from 1 to 10, that value that we just added, and if the cell value is 5, we display the message 50% complete, for example. And in some other scenario, we could look for something and then when found, exit the loop. So we just add here in the condition exit 4. Okay, now let's have a look at the for each loop. For each works in the same way, but it loops through a collection of objects or an array. So therefore, now it requires an object variable or a variant instead of a number. So for example, we can loop through worksheets, and then we would use the object variable, let's say WS, and we declare it as a worksheet. So that's how we declare an object variable. And for each WS in worksheets, and we can, for example, we can display the name of the worksheet. So msgbox ws.name, and then next WS. Or we can set a condition to look for a given worksheet, for example. So if, let's put here, if ws.name equals sheet 2, and I'm going to add here another sheet 2, then message box, I found my sheet. And here we can add the exit for. So once the sheet is found, we probably want to exit the loop. And the next WS. We can also loop with do loops. So a do loop is basically this: do, and then here, loop. And whatever in between, it will run again and again and again. So, and in this case, it will run forever. So be careful with the do loops, and you need to set a proper condition to exit the loop. That's why do is usually combined with while or until to set a condition. So we could say do while num below 10, and then here num equals num plus 1. And if we put a message box with num, this will run 10 times. So it's the same outcome as we did with the for loop. And we could do the same with until. We could write do until num equals 10. And we can also put the while or the until at the end of the loop. And that's how we use conditional statements and loops in Excel VBA. Variables store data in the computer's memory. And guess what? So do arrays. But arrays can store sets of data or multiple variables of the same data type. See this example here. We have a variable to store each month of the year. So variable 1 is January, variable 2 is February, and so on. So that would take 12 variables to store each month. We can store all 12 months in just one array. Let me show you in Excel. Let's add the months here in column A. So that's range A1 to A12, right? So an array can also be seen as a range of data. If we want to store this data set, we would use an array. Let's do it. We can name arrays following the same rules that apply to variables, and we declare them in the same way too. So we can use dim, static, public, but there's a small difference. An array declaration generally requires the number of array elements in parentheses, and that's for fixed size arrays. If not specified, the size can be changed during code execution, and that's a dynamic array. We could declare an array for this example in several ways. So, for example, dim month array 11, and I'll get to that in a moment, and as a string. So that's exactly the same format we were using for variables. Now, we could also do dim month array 0 to 11 as a string. That's a total of 12 elements, right, starting at 0. And we could also do, and this probably makes most sense, dim month array 1 to 12 as a string. In all these three cases here, the array is declared with 12 elements, and they are string values. In the first two cases, the lower bound is 0, while in the last case, the lower bound is 1. So if only one of the values is given, that's the upper bound, and Excel sets the lower bound to 0. But in many cases, and probably in this month's example, it makes sense to have 1 as the lower bound. So we can use this other declaration, 1 to 12, or option base 1 in the declaration sections here at the top of the module. So with option base 1, this one here is going to start now at 1, and it's only going to have 11 elements, so we need to change this to 12. The second example would keep starting at 0, from 0 to 11, and the last example will be the same. So any array declared with only the upper bound will start at 1. To assign values to an array, we need to specify the index for each item within the dimension in parentheses. So here's how we add month names to an array. Month array 0 equals January. Month array 1 equals February, and so on. Or if we keep the option base up there, or if we declare it with 1 to 12, that would be actually month array 1 for January, month array 2 and 3. And now that's simply the way to read the value in an array is with month array 3. So if we put that in a message box, it will give us, in this case, March. But there are other ways or other methods to populate arrays in VBA. For example, considering that the data is in range A1 to A12, we could rather assign values to the array looping through the range. So let's declare R, for example, for row as an integer, and then for R equals 1 to 12, month array R equals range AR dot value. So it's going to get the value of each cell in column A, so from 1 to 12, and it's going to put it in the array. Now our array is populated with the data in range A1 to A12. Let me show you that here. This is the locals window. We're going to talk about this later in the tutorial, but for now, this shows the array and the array elements. We can, of course, get the value of each element, of any element, as explained earlier. So if we say message box month array 12, that will be December. There is yet a more efficient way to do it. We can directly assign the contents in a range to the array with the value property. But in this case, the variable needs to be declared as a variant, though. And the array will have 2 dimensions. But unfortunately, that makes things a bit more complicated to access the data. But that's other possibility. So that would be the month array as variant, and then month array equals range A1, A12 dot value. Let me comment all that here and show you in the locals window. As you see now, it has 2 dimensions there, despite we just have data in 1 column. We can also assign values to an array using the array VBA function. This function returns a variant containing an array, so it also requires the array to be declared as a variant. So we do that like weekday array. Let's have another array and we declare it as a variant, and then we simply have a weekday array equals array, and this is the array function, and then we put the elements here, for example, Monday, Tuesday, and so on. And we can retrieve and display the data in the array as we did before with the index in the parentheses. So for example, if we say weekday array 4 and we put it in a message box, that will be that. So that's how we work with arrays in Excel VBA. We have already seen how to display a regular message box to show information to the user. We can also get feedback from users adding buttons to message boxes, as you can see in these examples here. We can also get information as text, numbers, even a range using input boxes. Let's move to the Visual Basic Editor and see more examples. The message box function displays a message box with information and buttons, and it stops program execution until one of the buttons is clicked. So message box, for example, this will run your macro. And if we play, we get the message box. And this should say OK. So the message can also be a value of a string variable. For example, if we put here, we declare the variable dim strmsg as a string, and then strmsg is going to be this message. So this will run your macro. And then we put the message box and then strmsg, and this will display the message. So this is very useful when we have different variables with different messages. So the message box function can take additional arguments to allow more powerful user interaction possibilities. After the prompt or message argument, we can add other arguments to determine the type of buttons, the title, and the help files. So as we said earlier, a message box shows by default the OK button. But that can be changed with one of the options in the table here. Let me show you. There are 6 button alternatives if we count the defaulted OK, which has the value 0. So we can either use the constant term or the value. So let's see an example. We're gonna have a message box with yes and no buttons. So that would be message box, for example, do you want to continue? And then comma, we put here VV yes no. And we could also use the value, so that would be 4. So let's play this one. And as you see, well, that should say yes and no in English. Yeah? If we put here 4 instead of VV yes no, it shows the same message. But if we add buttons, it's probably because we want to get some information from the user. So we need to know which button was clicked. The message box function can return a value that represents which button is clicked, and we can assign the result to a variable. So let me show you this other table which shows the possible return values for each button. So for example, if the user clicks OK, the return value is 1. If it clicks cancel, it's 2, and so on. And again, we can use the constant or the value. So in order to know if the user wants to continue or not, in this example, we need to assign a variable to the message box function, and we declare that as a message box result. So dim user ready, for example, that would be the name of our variable, as VV MSG box result. And then user ready equals MSG box. And now we have to use the parentheses, do you want to continue, comma, yes, no. And now we can set a condition to run a particular piece of code depending on the answer, either yes or no in this example. So if user ready equals VV yes, then we can have any code we want to run when the user clicks yes, and then else, for example, we could have here exit sub. We could stop the macro. And then end if. We can also add an icon to the message box by including the appropriate value or constant into the buttons argument with the plus symbol. And there are 4 icon alternatives. See here this other table. So we can have the buttons with the icon of critical, the question icon, exclamation, or the information. So let's have an example. We will have a variable, I'll call it MSG proceed, and is declared as a VV message box result, and MSG proceed equals MSG box, and for example, we can say changes cannot be undone. And then here VV OK cancel, so we're gonna have 2 buttons now, the OK button and the cancel button, plus VV critical, and this is gonna show the critical icon. Okay, and if we play it, there you see the critical icon over here, and that should say OK and cancel. Now let's talk about input boxes. The input box function is used to get a single piece of information from the user. That can be a number, a string, or even a range. So let's see an example of a simple input box asking for the user's name. The user input is assigned to the variable uname. So for example, dim uname as string, and then uname equals input box in parentheses, what's your name? And if we play, we see the input box asking for the user's name. We can also add the title of the input box and set the default value using the other arguments. So here we would add comma questionnaire, and that would be the title, and then comma name here, and that's the default value. If we play that, we see now the title, questionnaire, and there's a default value, and we can just change it, of course, adding the name. Then we can use that variable in the macro as any other variable. It contains the input value. So in this case, if we put that in a message box, MSG box, welcome, Mr., and then ampersand and the U name. And we can also set a condition here to check whether a user entered the name or not. So if U name is not empty, then we display the message box, the welcome message box. But else, we can display some other message or do nothing. And then end if. The input box function always displays two buttons, the OK and cancel button. And unfortunately, that cannot be changed. In order to have a message or input box with other buttons or functionality, or more sophisticated and powerful features, we can use Excel Userforms. Userforms are VBA programmable custom forms used to display information and get input from users. Either here or here insert user form. The user form folder shows up in the VBA Project Explorer, and a user form template appears in the code window. And if we double click on the form or on any of the elements, we get to the code window where we can write code here for the user form. We'll get to that later. So the user form gets by default the name user form 1, user form 2, etc. The name can be changed in the properties window. The caption, also user form 1 by default, can also be changed here. So the properties window is especially helpful when working with user forms because it shows and allows to set all parameters of the user form easily and quickly. The properties window also shows properties for each of the controls added to the form. Those controls show up in the toolbox when clicking anywhere in the user form. You can add any control by just dragging it into the form. So as an example, let's create a user form to request user information prior to proceed with a registration macro. Let's drag two labels. One will be the name and the other the department. Then a text box for the name and a combo box for the department. And the two command buttons to submit and cancel the form. A user form can be called out from any VBA procedure using the show method of the user form object, specifying the user form name. Let's change the user form name to registration form and also the caption here to registration. And then in a standard module, we'll have the macro user registration, and the first thing it's going to do is to show the user form. So registration form dot show. Let's add a button in the worksheet to run this macro. So that's how it looks like. Now your users can input name and department and submit the form. But for now, the form doesn't do anything because we didn't write any code yet. Also, the department dropdown doesn't show any values just yet. Let's see how we do all that. The user form code window opens when double-clicking in the form or in any of the controls added. If we double-click on the form, here we get the code window, and here on the top left we have user form, and on the right we can see all the events applicable to the user form. The user form click event procedure shows up by default as we click the form, but any other events can be selected. So we have just seen the user form events, but there is a different set of events for each of the controls, in some cases very similar or the same. The first thing we'll do is to get the initialize event, and we can remove the click event for now. The initialize event of the user form can be used to set properties or values into user form fields prior to being shown to the user. We may want to fill in some information in some of the fields of the user form, such as a text box, or set a list of items for a list box or a combo box. All of that would be part of the user form initialize event procedure. In this example, we want to populate the combo box with available departments to choose. So let's add an array of departments to the dropdown with the list method of the combo box. Note that combo box 1 is the default name given, but we could change that to any other more relevant name. So let's call it department box. Let's change also the other box. Let's call it name box. So for department box dot list equals an array with, for example, we're going to have finance, human resources, marketing, and production. Let's show now the user form and see how that looks like. So now the user can enter the name and select a department from the list. Username and department are parameters we want to capture and probably store in a variable or write directly into the worksheet. We will probably want to do that when the user clicks submit. So let's change the name, which by default is command button 1, to submit button. And let's change also the name for the cancel button to cancel button or BTN. Now, if we click the button, we get to the event procedure where we can write code that will run when the user clicks submit. In this example, we're going to add the name and department to two variables. So uname equals namebox.value and udept equals depthbox.value. And if we want to write the values into the worksheet, we just write range A2, for example, dot value equals uname, range B2, and finally we close the form, and we do that with unload. We can write unload registration form or just unload me. So that was an intro to user forms. Now let's see what types of errors we can encounter while coding macros, how to anticipate to those errors with error handling, and how to test and debug the code. We could say there are 4 types of errors in Excel VBA, but actually the syntax or language errors are generally typos that lead to one of the other 2 errors here, the compile errors and the runtime errors. The difference between the two is that compile errors are highlighted and break while compiling the code. Not a single line of the code actually runs. Then the first line or opening statement in that macro, the sub, and the macro name in this example, is highlighted when entering break mode. On the other hand, the runtime errors occur while the macro is running and breaks in the line of code that's producing the error, and that line is highlighted in yellow instead. Runtime errors can be anticipated using error handling, and there are 2 possibilities to do that. One is on error go to label or a part in the code, so it will jump to that line of code when the error occurs. Or we can use on error resume next, which moves to the next line ignoring the error. We can revoke an on error statement using on error go to 0. Excel VBA comes with a number of tools to debug the code and errors. We've talked already about the break mode, which highlights in yellow the line causing the error. We can also step into the code line by line, and that's here or pressing F8. That's very useful to see what and when it's happening. We can also add toggle breakpoints to run certain parts of the macro. The locals window allows to see the value of variables and expressions while running the macro. It is very helpful when used along with a step into. The watch window shows more or less the same, but for a specific expression or variable. And we also have the immediate window where we can write code on the fly. We can also use debug print within the macro to show the outcome or value of variables, for example, in the immediate window. Have a look at this video up here to know more about debugging and error handling in Excel VBA. And this was a condensed introduction to Excel VBA and macros in just 1 hour. If you want to learn more and understand each of these topics in more detail, I strongly recommend you watch the entire Excel Macro Tutorial for Beginners playlist in this channel. It consists of 10 videos covering each key area. If you prefer to read, you will find the training for beginners and much more in my blog Excel Macro class. I strongly recommend you get the Excel VBA guide for beginners too. It's just 75 pages to read and it will give you a solid background. Plus, you can always come back to the book and easily find what you need to know through the list of contents or the index. And if you still want to learn more, there are a lot of simple macro examples here in this channel and a bit more complicated macros too. And you should definitely know how to use Excel VBA objects.
And for that, you have the Excel VBA Objects series playlist in this channel. Or you can get the Excel VBA Objects Guide for Intermediate in Excel Macro class. And there's yet a lot more to come, so stay tuned and thanks for watching.